Okay, now. We still have trouble seeing small letters. Yes. Yeah. What I have said is so we are about annotate meaning within information represented using different modalities like text in textual form, and to make it kind of available in a standardized way for machine reading to begin with. And in this example, so we have a textual information, John loves Mary, so we want to load it with meaning. And to do that, we need to have descriptions of what each of these terms mean. And we have this description in, if you wish, reference bases. We call them ontologies. So it's a collection of definition of terms, basically. And the annotation would be in the form of connecting, well, certain tokens with references to the definition in these ontologies. And ontologies, they will be, they need to be available somehow. So you need to indicate where they are located. And in this, so we are using, or we are using the fact that ontologies, which are actually file, well, normally XML in XML format, and they will be placed on some web servers, publicly accessible, obviously, or accessible within the operational domain of your system. So what we will do now, we will starting with simple examples, we will see how we can use resource description framework to annotate these resources, different resources. So the format of RDF statement is subject, predicate, object. And this object, it can be either a value or another object, basically. And so it's not a rocket science, as you see. So you say, okay, this is the object. So you, and in this case, it's a web page of some person, and then you say that okay, the creator of this web page, and then you give a name. So this is a value. So what you can do, you can use a couple of syntaxes here. So one is called serialization syntax. So you start with the indication that is an RDF statement. So basically, this is the most kind of complete description. So with no shortcuts. So so you say that subject is, well, the web page, and then you say creator within certain domain S over here, and then you give a value. So this is kind of definition of an indication of variable, if you wish. Well, yes, here is the subject. This is a predicate. And predicate is defined in some ontology, and an object. So, and to complete this figure, then somewhere in the text where you do this annotation, you need to define places where you can you take all these definitions. So, so somewhere, in the beginning of this annotated document, so you say where to take the RDF definitions, so now for names, and for syntax, and also indicate the ontology in which different fields are described. And as I said, so here is the template. So it's you either create statements describing a value, or you can also describe an object, and then in this way, so you can you can create kind of a linked, so semantically linked information, so with links between different objects. So, and these are the two things. So here is the case where we have a RDF statement annotating a value to subject, and here where we link an object. So we say that well, this is the web page of the person, but now we link it to an object. So, and you can find its description here, and in this ontology, which is so this Pelle Johansson file. So it's a file name. So somewhere inside, later you will see it. So there is a hashtag defining an individual. So so with all the parameters, amongst others. So they are you will find a name also as a literal. So now, again, this format is, well, it's kind of long. So there are different other formats which are more readable. And there are tools that seamlessly convert from one syntax to another. So just again, nothing to remember really. You all can read about it in the documentation, but I want to show you some tools that you will need to verify the correctness of this of your statements. So, for example, yeah, I can hint you that in second quiz, so I may ask create a description of car models. And then you need to write the description, so like in an RDF format, and verify its correctness. So this is the tool where you verify the correctness. So let's try it out. So let me see. To try it out, I want to just copy this thing. Let's see. And I want to make it bigger, maybe, so that you will see. And here, so here you paste your RDF statement, and then you have different choices for the output. So I will choose now this triples and graph, and then in which format to represent a graph, so that you see what is the different. And then we say parse RDF. So let's see. No. What's wrong? Subject, no. That's interesting. Maybe it didn't like the copied characters. So let me see. No, and that means that so we approach the break. So let me just debug it very quickly, and in 5 minutes we resume. So I hope it will be working. So let's have a break now, and yeah, probably that one. You have a question? Go on.
Well, it's just the next stage.
Yes.
But
Okay.
this is used in websites and stuff, or
Huh? You can use it to annotate anything. So, so that's not for, only for websites or such.
I guess it looks a bit like HTML, like
Yeah, but yeah, it's a syntax. Well, it's an XML.
okay.
I mean, in general, it's kind of very similar to XML. It's a flavor of XML.
Okay.
Yeah. So now I debugged it. So the point is that so this is a format of knowledge representation. So you can represent in this form, you can represent like anything and not related to even the web page. But what is important is that you have a kind of digital incarnation of that also. So basically here is the web.
We're describing it on this.
Restore any.
Okay. And like, you are from this
It's a person who has that page.
Okay.
But the web page in itself is just textual information. So I mean, it has nothing to do with the and here, so you link in the statement, you link this web page, so which is the textual information, and you say, so now we start to populate it with some meaningful attributes, like who is the creator, when it was created, under which department it is created, etc. So I mean, and this is characterization of a resource web page. So here instead of web page, it could be any other resource, like audio file, video, or just URI, so it is not of the class, you can still basis it's signal, so you know how things and then you the statement to link to that these are producer, it's something this is different three sticks. And then what is nothing possible. Have the description. So it's not like a single database where everything was here. So, but you enable kind of distributed through to semantic search. Like what's like you can say, okay, so you can create logical like statements, like almost like logical predicates, like just show me the cars produced in the same city as this person lives. You see? And then, so the search will be, I mean, on normal text, well, Google can do something definitively correct, but it does simply on kind of score match. Here, instead, it would be first derive, okay, so same city as this person lives. So it first goes to this person annotation, finds the city where it lives. Then it kind of connects it to its field of car producer, and then derive that it's, for example, Volkswagen.
Yeah.
It's a different kind of search. It's more kind of meaning-based search. And so we start with very simple descriptions, and then we will kind of continue to more and more complex.
Well, will you say that RDF is a very simple way to order data?
Well, later on, so we will convert to more complex. So it all it starts with RDF in the bottom, but then we will talk in like not tomorrow, but or maybe even tomorrow. So we start talking about ontology web language. So OWL, OL.
Okay.
So it is more kind of it is created. It is derived from RDF, but it is more tailored to creation of complex relationships, like some more streamlined. Huh? Again, so yeah, so it was created in the context of semantic web, but it can be used to describe any ontology. So the ontology is not web specific. Ontology is just a collection of terms and definitions, if you wish. And OL is a language to really create a knowledge out of this definition. That so it really creates particular links. So this is connected to this, to this, to that.
Okay.
I hope in yeah.
In the lab 2 is going to be about
ontologies.
Yeah, and the structure of.
Yeah, exactly. So in lab 2, so basically it's a good moment, a good point to talk a little bit about it. You will be given a tutorial. So actually, maybe it's a message to all. Hi guys. So we start. So I can tell to all. A few words about lab 2. So now I think you are approaching the end of lab 1, and I know. I mean. Technically, it is more challenging than lab 2, but I mean lab 2 is I give you somewhat less points. But in lab 2, you will work with this stuff, but you will be given a tutorial. So it's a lengthy document, and it's more of kind of the idea is that when doing these steps. You will get a kind of more or less full picture on how to create ontologies. So you will be working with creating pizza ontology and defining your flavor of pizza there. So the problem was that I just copied a part which is not complete. So I copied just this RDF description, but didn't include the header of the statement. So when I do it, indicating where to take the syntax, where to take the how to resolve this S, which is ontology, so it becomes parsable. And what you do here, so you display it in two variants. So you first of all, it dissects this description into subject predicate object. So you see, so this is a subject, which is a web page, predicate creator. So take creator from this, well, schema or ontology, and this is a value, a literal value. But also, so and that's an interest later on interesting thing. So it gives you a kind of graphical representation. So kind of very primitive knowledge graph. So how different resources are connected, but here it's a well, resource connected to terminal value. So in the same way, so if now I would do this, and that is the statement with which doesn't terminate in a value. So let me see, I go back. Yes. Well, now instead of value, so here you have a link to the description of this person. So far so good. So let's see. So now, as I said, so there are different ways. So just for you to recognize, so you know that, as I said, some of them are created for brevity of reading of the developer. So there is an abbreviated, same abbreviated statement. So here it's so you say, so this is description, and then you just yeah, well, we'll basically make shortcuts to define subject, predicate, object. Yet another syntax is created to describe more complex statements. So it is called N3 notation. All PDFs are available as if you have seen them on the web. So and they contain links to where you can find this more detailed information. But again, for quiz, I think this the slides themselves, so they suggest quite a good extract of that information. So notation 3 of RDF statements, or N3 notations, it's a non-XML format. So a non-XML format, which then automatically, so I will show you the tools, can be rolled out in RDF statements, which could be parsed and displayed. So the difference is, as you see here, so I will just zoom in this mode. So this is an RDF statement above. And in N3 notation, so you just state triples. So subject, predicate, object. So again, some details which I will not probably vocalize. So there are some shorthand notations as well. And basically this is the syntax. Importantly, so each line in N3 notation should end with a period. So that's kind of, I mean, technically important. And so now you will see some details, but I mean, so it's same stuff. So statement of a subject that has a value and a subject that has an object translated into or written in N3 format. So you describe an ontology and then say subject, predicate, object, period. Subject, predicate, value, period. Done. Okay, so it's better to switch on to this side. So this format was created for again better readability for an expression of statements with some repetitive parts. So, for example, if you have commas, so they are equivalent to just repeating the part before that. So what do we have here? We have A, B, subject, predicate, and we have object C through Z. So if in kind of standard way, so you would create this many statements. So you can create a statement using commas. Semicolon. Here, you see, what does it do here? Yeah. So again, so we have subject as a repeating entity, and predicate objects are different for each subject. So with semicolon, we separate pairs of the description. So and they can be combined. So for example, a statement like A, so subject, predicate, C, D, and then E, F, and then G, H, I, G. So so in one line, so you actually encode many statements. So first you create two statements for the first part before first semicolon, A, B, C, A, B, D. Then A actually persists through all the definitions as a subject. And then you spell out B, the second part, so A, E, F. So there is no repetition here. And then we have three variants of G. So the G is a predicate and three objects. Then you may have also empty statements. So let me see, or the statements in brackets like this. So what we have here, yeah, it's a blank node. So we have so we have two statements here. A, B, so and the subject is and the object is blank, so it's unknown. So it is possible in some cases. So so example is spelled out here. Again, probably you can first read it. We can return to it next time. And the same goes for the second statement, where which misses the subject part. So all in all, so I mean, all these three things, comma, semicolon, and square brackets, can be combined to annotate this or to compactly describe many statements. So let us do some simple practical example. So this is a story about myself. So and then again, so you can in the similar fashion, so you can think of annotating your own kind of life story. So here is me. So my name is Evgeny, and I'm my gender is male. So this is my mother. Her name is Zoya, and I'm fond of fishing, and I'm fond of paddling. So these facts, again, so it could be a text in which I could annotate the different parts, so adding them to meaning, and the meaning is described through RDF statements. So these are the triples. So Evgeny, gender, male, and you take this statements from some ontology which is available on that server. So now it's maybe irrelevant. Starting from tomorrow, I show that it's an existing server with an existing file, and you will see some more information inside it. But just for us to create and parse statements, it's enough that we have this information. So let me see. So in M3 format, so the same story is described like this again. So we define two ontologies. And importantly, yeah, you see, so different aspects of a resource can have definitions in different ontologies, obviously, and therefore it's important to define detail from which ontology specific definition is taken. So let me take now this part over here. And now I will show you a tool, another tool, which first converts this M3 format into a RDF statement, which then can be further copied into a tool for validation. So yeah. So let me see, Control plus. So I copy it here. Hopefully it will work now. So this URI is not really important. So you can, yeah, let it guess for the format. And I want to have RDF XML as an output. Submit. Yes, and here it is. So this tool I used to convert. So if you just use this M3 notation without conversion into in the validator, so it won't tell you anything, or it will fail to display it correctly. In reality, so if you have a development environment, so this translation obviously is done automatically. I'm just showing you some more or less manual transition, but that's what you I'm asking you to play with, at least in this course. So we are not ontology developers. I mean, you will use for the ontological description, you will use IDE. Which hides this textual I mean, this kind of XML stuff, and allows I mean, it has nicer graphical interface. It's called Protege. So I hope to start with it tomorrow. So now we copy it and we go to the validator. Go back. Wait. And see. Here we go. So all four statements are parsed, and here is the model of our knowledge. So we have subject, different predicates defined somewhere, and object. All right. In the same manner now, so now we will modify the description to make it somewhat more complex, and this goes towards this kind of more complex knowledge graphs, as I probably tried to make this example during the break, so that later on you could kind of merge information from different parts of the graph to answer queries. So now I will try to represent a knowledge that I have the same hobby as my mother has. So I want to link my hobby to the hobby of another object. So we add a new fact. So that I have a hobby which is also a hobby of my mother. And so this is rule number 5. So that's what we the only difference from the previous description is that we have subject me. So we take predicate fun of from this ontology, and then we have, you see, this is we have in brackets. In brackets, we have hobby of my mother. So by these we so it's a please not here. So it's this predicate. So this is a predicate. Is hobby of. So it means that so somewhere in this ontology, which this is the file of ontology called life and north, not all. So there are description of hobbies just as resources. So there can be different hobbies. And then these hobbies further on can be precise. So they can have a field. So when you create an instance of a hobby, you can specify this is a hobby of somebody. And so this is an example of the bracket. So you don't know what the hobby is. So yes.
What is OLV used for, like usually, like, or in general today, like
to describe ontologies, so knowledge bases.
But this is very common to use, like ontologies to sort things.
It's still common. I mean, it's a good question about practical usage, you mean? I mean, from the top of my head, maybe I can comment tomorrow. I can dig up some examples of using ontologies. I hoped really, I mean, that this topic would be covered by a colleague of mine, but unfortunately he's not available for December, and he works with ontologies for optimization of energy usage, like between different different actors somehow. But let me find some good examples today. Maybe I can come back tomorrow. Yeah, but the point here is that with this example, I want to demonstrate this blank node concept. So the blank node is that we don't specify which hobby. We just say, okay, something which is hobby of somebody, of some object. And so again, so let's parse it. So this is a compact way. So you see, so we have only single line here for defining a hobby. So it's subject me, predicate is fun of, and then we have fishing, comma, paddling, comma, something that is hobby of somebody. So let's see how it will change as the data model graph has changed with this definition. So we do again. So we go first and translate this notation tree stuff into RDF. So guess, submit. So here is the stuff. So you see, the last statement is translated. Is fun of, and then a description. Is hobby of, like this. So let me see. So let's copy this whole thing. Oh, no. We'll see, and we go to and see the data model graph. So, whoa, what is that? Ah, yeah, because it's an empty, a blank node here, so it doesn't have any reference. But how does it look now? So let me, maybe I need to do it like this. And can I do like, yeah, you see? So this is me. So it's a story about myself with me as a subject. I have several predicates. And so one of the predicates is my mother's name, or that I have a mother who is a resource with some other description. And amongst this description, it's a property. She has a property, like she has a hobby. But normally, so looking a little bit ahead, you can define in ontologies. You can define bidirectional kind of bidirectional properties. So reversible properties. I don't remember if it's correct terminology, but you can define two properties. So or you can say that has hobby is linked to is hobby of some other description, and that is what is shown here. So I have some hobby, which is actually part of this description over here. But you already see that, I mean, in this way, so we kind of translating a story which is otherwise just a text into something more structural that and machine readable. And again, so this is a primitive example, obviously, but this is a way to further describe very complex graphs and relationship between different resources. Yes. So basically, I think we shall stop at this moment. What I want to ask you is to try it out and play a little bit around with this a simple way of annotating resources, and in a similar fashion, maybe define different other properties, describe your own story. I mean, this, we don't need to do it now, but I mean, you can do yourself at home. And so what I want is that you actually try out these two tools. So one for translation of entry notation into RDF XML description, and another one for verification, so that's of the correctness of the statement, so that you see subject predicate objects. You can see different types of objects, like terminating values of different types, and other objects, and that you're able to see graphically how they all connected. So that will be this super simple task for today. So tomorrow we continue with the more complex development, so including the relationship between different objects. Okay, good. See you tomorrow then.